Okay, with that, we're going to move over to Dr. Edwin Ritchey. Most of you on here already know Dr. Ritchey. He's a soil extension scientist. Does a really good job. Has done a lot of work with manure management as well. Really important topic, particularly in Western Kentucky, and taking those products and making them a viable fertilizer option for a lot of our fields. Edwin's done a lot of really good work since he's been here as faculty. And so, Edwin, we really appreciate you being on, and I'll let you take it from here.
All right. Can everybody hear me? Well, I'm going to take that as a yes and move on. So today I was asked to speak about soil sampling, and thought I'd bring in, if we had a little time, about how the fertilizer recommendations are developed. So the critical part of soil testing and soil sampling is getting a good sample. Anyone that's heard me give this talk before remembers how much I focus on that representative sample. There's roughly 2 million pounds of soil in an acre furrow slice. So that's 1 acre. If we're looking at a 10-acre sample, that's 20 million pounds. Of that 20 million pounds, we're only looking at about a teaspoon for your P, K, and your other bases, and 1 tablespoon for pH. So that pint box or bag that you fill up really needs to represent that area that you're trying to get a good value on to make a good sound fertilizer recommendation. So what we look at are uniform areas. We base that on drainage, cropping history, erosion, a lot of the things that Hannah and Sam talked about earlier. If we have a 20-acre field and 3 acres in the middle of it grew tobacco, that 3 acres is probably going to be different than the other 17 acres out of that 20-acre field. So to get a uniform sample, a soil probe is by far the best tool to use. Some people might want to use a shovel. You can use a shovel, but you need to make sure that you have the same thickness, same width from the top to the bottom. If you're taking a 4-inch sample and it's 4 inches wide at the top of that sample at the soil surface and only 1 inch wide at the bottom at 4 inches, then you've skewed that data or that analysis towards the top. So you need to make sure that it's a good representative sample. We don't want to use galvanized buckets that can contaminate our sample with zinc, so a good clean plastic bucket. And then I like to air dry it. Just gives, you can crumble it up a little bit better, get a better representative sample to put into that bag to send off to the lab, and then put it in an appropriate bag, label it, and send it off to the lab. So we recommend no more than 10 to 20 acres per sample, and that really depends on the variability inherent to that field. So this is a farm that my family actually purchased about 25 years ago. It joined up to the family farm that my grandparents bought back in the late 30s. And
hey, Edwin.
Yes.
We don't see the picture of the farm.
You don't see the picture of the farm. How about now?
Yes.
All right. Thanks for letting me go for 4 minutes. Thanks for catching that, Hannah. I guess I didn't hit share. I did hit it, but it didn't take. So anyway, here is a picture of the family farm. There's roughly 15 acres in this area. This blue shaded area, well, let me back up a minute. This was a dairy farm for about 40 years. So this blue shaded area was where the cattle stalled before coming into the milking parlor. This has since grown up since we took this picture, but right in here was the milking barn. So they stalled in here, they'd come in, go into the barn, come out and leave. So of that 15 acres, there's roughly 4 acres that had a lot more manure than the other 12 acres or 13 acres or 11. So if we would have used this area and included it with this 15 acres, we're going to elevate our soil test results, which will likely decrease our soil test recommendation. So this area here should be separated from the rest of the 15-acre field. So that's one type of variability to consider. Now here's another one. This is just an example. I used a 120-acre field. Each of these squares represent a 2.5-acre grid. Now we have 2 options within that 2.5-acre grid. This top option has high, medium, low all through that. It works out to a medium if you do the average, but you go from a high to a low to a high to a medium. So there's a lot of inherent variability within this small area, or you can have, you know, more uniform area within that 2.5 acres. Hopefully, for sake of management, we're looking at this bottom example. It makes it a whole lot easier to manage. So if we look at the bottom example, now I have it over here to the right. Hopefully we have something that would break out like this. So we have zones that we can look at. We have a low testing zone in one area of the field, maybe a high testing zone and a medium. So now I have potentially 3 different management zones I could separate and manage differently. So that's one of the examples where it shows intensive sampling can help with your management decisions. This is real data. This is a project that was funded by the Kentucky Soybean Promotion Board. This is the second year. This is the first year of data. We managed this, or the farm managed this, I don't know how long prior to me taking it over, but for a long time. So this was managed as a uniform production field by the farm. If you look, we go from 207 to 177, a low of 151 pounds of soil test K per an acre, to a high of 269. And if we look at it, kind of averaging it across this way, through this row, we had 175 pounds per acre. Our recommendation averaged to 70. Same thing here. There's a mess up with the sampling here, 60, 70. Now, if we look at it this way, we see similar variation, but we do see a spot here where we have a recommendation of 70, 80, 70, 80. So that right there might pop out into a different management zone, but then it comes back to scale. So if this was a 20-acre field, I would probably break this out into a different management zone, and then we would have different, we would have another one where we'd probably have to add a lower amount of fertilizer because it has higher soil test values. However, these are small plots. This is a 10 by 50 plot, another 10 by 50 plot. So this whole area right here is only about 3/10 of an acre, or 36 hundredths of an acre. So even though we had this much variability within a small area, it shows what you would see and most likely in most fields that are being used for production ag. The other thing that I'd like to point out that comes back to Sam and Hannah is, even though we manage this the same, we have things that were influencing these different soil test results. We had soil test results that were lower in this area here and higher recommendations. that over time, year after year after year, was probably removing higher yielding, removing higher rates of nutrients, and we were applying that flat rate across the whole field. So all this comes into making our different soil test recommendations. Out of that same field, this was a soil fertility trial. We had band or no band, and then we applied the UK rate plus 25% or minus 25% compared to our check. So we were in that medium range, the low end of the medium range, but we really didn't see a whole lot of difference in our yields. It went from 45 to 48 to 47 to 50. No statistical differences between yields at this rate. That means we're applying enough even at our low rate to maximize yield in this environment. We did see a slight increase in tissue, potassium tissue content, but really nothing to get excited about. It did show that we had a little bit more uptake with our added fertilizer compared to the check, but nothing really big and nothing that resulted in the yield increase in this environment. So back to collecting a soil sample, how many do we need to collect? Well, it depends, but generally more is better. For this procedure, this practice, I'm looking at randomly collecting them across the field. I would say a minimum of 10, but 20 is probably going to be better. However big the field is, the more you can take, the closer to reality you're going to get with that sample size. And again, make sure you mix it in a plastic bucket and avoid the contamination with the galvanized zinc. Here's my little $3 bucket. I've probably had over 2 or 3 tons of soil in that bucket since I started 10 years ago. I use it a lot. It's easy, cheap, easy to clean. Take my samples. I like to crush them if I have the time, if they're not too wet. And then I have a nice powdery stuff that is homogenized when I pour it into the bag. So if I happen to take more than the bag needs, I'm not getting a big core versus leaving one. I've mixed it. So I've mixed it across the core. Again, a little bit better representative sample of that area. So when do we collect the sample? Well, doesn't really matter a whole lot. Fall versus spring, they differ some. The bigger thing is to watch that trend over time, and you want to collect it at the same time each year so you can watch those trends. This is some work that Lloyd Murdoch did. It's a AGR publication, but this first figure 1, it shows what our typical soil pH would do as a water pH. As we went from spring into summer into fall, it dipped and then came back up. Well, we have a low pH here in the middle of August. We have dry conditions present. So our plants are pulling water and fertilizer salts from depth, putting it at the area where the plants can use it. That fertilizer salt is going to help displace hydrogen, which is going to result in a lower pH. Now, Frank Sikora was aware of this, and he made an adjustment. All you agents out there, I'm sure, are well aware that we now do a salt pH. That salt pH helps reduce this big fluctuation in pH due to moisture content. But regardless, we want to take it at the same time every year, very similar, so we're looking at that same type of response. Here's potassium. It drops, it goes from a high, drops down, and then starts going up somewhere around black layer. So what's going on with potassium? Well, potassium is very mobile in the plant. It's easily leached out of the plant. So as the plant is utilizing it, taking it up, utilizing it, incorporating it into the biomass, and then we start start to senesce. As the plant starts to senesce, the leaves start dying, it rains, it's leaching this potassium out of the leaves back into the soil. So it goes down and then goes back up. So again, if we're looking at a sample at July versus March, they could differ greatly. So we can avoid a lot of that by just taking the same sample, or taking that sample at the same time year after year, and then looking at our trends. So how often, and that's really specific to the crop, higher the value, the greater the removal, the more intense sampling. You're looking at $7 a sample plus the time. So let's just say you have $10 per sample in it, and it represents 10 acres. That's $1 an acre. What other practice do you do in your farming operation that costs less than $1 an acre? So that's money well spent, provides a great amount of guidance, so you can make sure you're not over or under applying your fertilizer. So the high value crops, dark and burley tobacco, high removal and high value alfalfa, high removal silage corn or grain, small grain baleage. So these crops would benefit, or your yields and your management would benefit from more intensive sampling with these crops versus the others, like a corn soybean rotation. You can get by every 2 to 3 years with that and apply accordingly. So what's our sample depth? Well, it depends on tillage. For the University of Kentucky, the work that was done years ago, and it still holds true, we're looking at a 6-inch sample or to the depth you till for a tilled system, or a 4-inch sample in a no-till system or a pasture system. If you're looking at minimal tillage, like a turbo till where you're disturbing the soil 1 to 2 inches, I would still go with that 4-inch sample, because you still have the stratification of the nutrients. So that's the best approach with that. This was a little thing I did for the cat school a few sessions back. It really pretty neat, and it really surprised me how much we saw this. But I had 2 fields. One of them was a Kreider silt loam right across the road, and then we had a Zanesville silt loam on the backside of the station. Both rotations were either corn soybean or corn wheat double crop beans. We had no-till, so we should be sampling to a 4-inch depth, and I just laid out an area within the field, a 5 by 5 square. So we had 4 spots within that 5 by 5 square. This was roughly a foot, another foot. So I sampled 12-inch sample, 12-inch sample, 12-inch sample, 12-inch sample. Then I took 2 6-inch samples, 2 6-inch samples, 2 6-inch samples, 2 6-inch, and then 3, 4, and so on. So I tried to collect similar volumes, but it was from a very, very small area within a field. Remember, from this corner to this corner, we're only looking at a 5-foot square. So very, very small area. So does soil test depth really matter? If you look here, 0 to 1, 0 to 4, 0 to 6, 0 to 12 for phosphorus. As we increased our soil depth, our soil sample depth, we decreased our fertility level. Same thing for potassium, go from about 1,000 to 600 as we increase with depth. Now that's on the Kreider. That's tremendous fertility. I don't know exactly what happened before we took this over, but wow, you could just about sell this soil for fertilizer, at least a top inch or 2. Now the Zanesville, it's a little bit different. Same sample depth, but now our soil test phosphorus started at 90 if we just looked at the 1-inch. Now a 4-inch, which is the sample depth we should use for this rotation, 45 down to 32. And when we go down all the way to 12 inches, we're looking at 15. So there's a pretty big difference there. Soil test potassium, same trend. So does that really influence our management? Well, it depends. On this crider, we're above that critical threshold that we would expect to see a response. Therefore, our recommendation, regardless, is 0. Even though we had a huge difference in soil test values, we're above that critical value. With the Zanesville, however, it does matter. It went from 90 to 45, so a 0 recommendation to 40. If we go deeper, now it's 70 to 100. So depending on what that soil depth is, we might either be under applying our fertilizer or over applying. Same thing is seen for potassium. So soil test depth does matter. I'm going to skip through this real quick and get to the last part and just kind of reiterate what we were talking about. So does our soil test matter, or our soil sampling matter? Yes, it influences it a lot. We have the uniformity. We need to make sure that sample is representative of the area we're trying to evaluate. Remember our soil test depth, 4 inches for no-till, 6 inches for conventional till. Try to keep those samples small. You know, a 10-acre field is probably going to be better represent that field than a 20-acre field. But when you start getting above 20 acres, there's so much variability that you don't know what you're looking at. And how often? Generally, the better, the more often you can, the better. But for sure, the higher the value, the higher removal. You know, look at an annual or every other year, just because it's such a cheap and useful operation that can lead to a more profitable enterprise. So that is what I have, and I believe I stayed on time, and I will be happy to answer any questions at this time. Thank you, and Hannah, thanks again for letting me know my slides weren't showing.
Thank you, Edwin. We appreciate you getting in there and talking about that. I think showing those differences in how the soil test values change when you're doing those different depths. If nothing else, everybody should be questioning if they're not pulling off their own soil samples. They need to be questioning how their soil samples are being viewed.